Hey, welcome back, and today we're going to discuss polar coordinates in when it involves graphing. So we're going to talk about graphing on the polar grid using polar coordinates or graphing a polar equation. And so in order to do that, we're going to start with symmetry. Okay, symmetry is always a good thing to start with because symmetry allows us to be able to graph things more easily in a lot of respects. But we have to test to see whether that equation is going to be symmetric. Now, with the polar grid, we can think about being symmetric with respect to the y-axis, the x-axis, or the origin, but we don't use those terms. In the polar grid, we talk about being symmetric with respect to theta equal to pi over 2, right? So again, that's synonymous to the y-axis, or being symmetric with respect to the polar axis, which is the x-axis, and then instead of the origin, we call that being symmetric with respect to the pole. Okay, so now the test that we're going to do is the test to see whether a graph is symmetric about any one of these or more than one of these. And so it's very simple. For the for theta equal to pi over 2 or 90 degrees, all you do is replace r comma theta with the opposite of r and the opposite of theta. If you do that and you get the equivalent equation out, then it passes, and it is therefore symmetric with respect to the line, the angle pi over 2. If you want to test whether it's symmetric with respect to the polar axis, then you're going to now there's two different ways to test this. Okay, you either replace r comma theta with either r comma negative theta or the opposite of theta, or the opposite of r comma pi minus theta. Okay, so you could use either one of these. If it passes either one of those, then it's symmetric with respect to the polar axis. Okay. If you want to see if it's symmetric with respect to the pole, then you replace r comma theta with the opposite of r comma theta. And so now if it passes these tests, then it's going to have that corresponding symmetry. If it doesn't pass, then it's not necessarily the case that it doesn't have symmetry with respect to the pole or the polar axis or theta equal to pi over 2. Okay, so it's not perfect, but at least it gives us an idea of symmetry when it passes. Okay, so we're going to do some examples of testing for these symmetries, and then using these symmetries later to graph the graph of the polar equation on the polar grid. Okay, have a great day, and we'll do some examples.